And first, I want to kind of go over some key concepts so we don't get confused, right? And first, there are some join types: inner join, outer join, cross join, semi join, or as of join. And those are logical views of a join. Those are the SQL or the SQL function that the user writes that describe what they want, right? And then we have join algorithms, right? You probably heard of that. Hash join, parallel hash join, merge sort join, or yeah, there's many more. And this is actually how a join is executed on a single node, right? This is only on a single node. And there are join strategies, and this is the key. And this, you can have a single instance join, like a local join. We call it a local join. We can do a collocated join, broadcast join, shuffle join, and this is all on a network level, right? So this is really single node versus distributed, and the strategy of distributed joins, right? And here I want to ask you a question. So does your workload or your OLAP workload fit in one node? The answer is probably no, right? And a join happens to be the most or one of the most expensive operation you can write with a SQL query, right? So if your answer is no, then we need to focus on the join strategies, because all of the others, especially the join algorithms, only associate with one node, right? And the join strategy is the one we're going to focus on in this section. So just exactly how to execute joins at scale with many instances. So single node join is very different than distributed join. Distributed join operation, one thing needs to do is that make sure all of the worker nodes gets the right data that it can work on, right? So it tries to minimize, during the process of distributing the data, it tries to minimize the network utilization. So that's the amount of data that's being transferred between nodes. And it tries to minimize the memory utilization, right? And that's the amount of data that's being processed in memory. You don't want the same data that's being copied everywhere, but you don't get multiple of performance, right? And here I want to introduce something it's called data shuffling, right? And so why does it matter so much for joins? I'm going to use the next 4 or 5 slides to talk about that, right? Data shuffling is basically shuffle the data to all of the worker nodes based on a join key, right? Based on the key, shuffle all the data to the right nodes. So you can shuffle any table, like your left table or the right table, right? And this is a key to truly scalable distributed join. I'm going to use some examples like shuffle join, broadcast join, bucket shuffle join, and some other like localized or single node join to demonstrate this, right? And first, let's talk about some different join strategies, right? And the first type is kind of like, say, local join, kind of made this word up, versus distributed join, right? And local join, you can think of them as a single node join, right? And to use multiple nodes to process a query, with a local join, it requires a certain data distribution, right? So you first have to organize your data in a certain way for the join to work on multiple nodes, right? And distributed join actually sends the data on the fly during the join query execution, right? And first, let's look at the first local join. So first is collocated join, right? See, this kind of join doesn't really send data, so it relies on the both tables to be distributed on the same join key. So if you want to use like collocated join, you need to know about the query, at least about the query, the join condition beforehand, right? And the join is done completely locally, so there's no network overhead. It's very fast, but it's not flexible at all, right? Because you need prior knowledge of the query before actually ingesting the data, right? And this does not require any data shuffling. And the second one is a distributed join. It's called broadcast join. It also does not require data shuffling, but it has many shortcomings, right? So what it does is that you have a left table that's, so assume it's a bigger table, and you have a right table, and that's a smaller table, right? So it broadcasts a copy of the smaller table to all of your worker nodes. So let's say we have 3 nodes, right? And the right table is 1,000 rows. So the network overhead is actually 3,000. It scales not only with the size of your data, but it also scales with the size of your cluster. And that's very expensive. And the right table needs to fit into every single one of your worker node, or else it's not going to work, right? And this type is only suitable for small clusters, or cost effective for small clusters, or joins with a very tiny right table, right? And this is actually the only kind of distributed join ClickHouse can support, because it doesn't really do data shuffling, right? And then let's talk about shuffle join. So shuffle join shuffles the data between the both tables to all of the nodes based on the join key, right? Say if you have 200 nodes, the number, the data that's being transferred in the network and that's being processed in memory is still 5,000 rows and 1,000 row, right? So it's very scalable. So the more nodes you add, the more performance you're gonna get, and you use the same amount of memory if you want to run the same query, right? It does not scale with the size of the cluster, and this is the key of achieving truly scalable join, uh, like in a distributed fashion, right? And Saras also has other optimizations. Like for example, we support bucket shuffle join, right? So if the join key already aligns with the distributed key of the left table, we can only shuffle the right table. So it's much cheaper, right, on the network. So it's automatic and doesn't require any more configuration, right? But the ability to perform shuffling is the key here, right? And let's take a look at what we just talked about, right? Broadcast join, shuffle join, bucket shuffle join, collocated join. Oh, and replicated join. Replicated join is actually um, just pre-computed broadcast join. So you just during data ingestion, you just replicate the right table into every one of your node. So basically, use your hard disk, right? So replicate the tables without without the ability to do data shuffling. The only option that ClickHouse has is that either first you have to know about your query pattern beforehand, and your data distribution needs to base on that, so that you can do a collocated join or replicated join, right? Or you can do a broadcast join where the right table needs to be very small, right? And any other scenario, if you want to join two like billion or hundreds of billion scale table together, both are big, they're not going to work, right? You need shuffle operation because it's going to bottleneck on the size of its single node.